Last section of this practice test are the one-step proofs. So remember, these are proofs where you do not need additional steps to be able to finish the proof. The given has all the information that's needed to be able to make the conclusion. So for example, number 1 here, that length is 8, this length is 8. We want to conclude that those two segments are congruent. Well, two segments that have the same measure are congruent. Okay, so we just have to write a general if-then statement in the correct order here. Remember that really all that's happening is your if is going with the given information. We're saying if this kind of stuff is true, then the prove statement is going to be true. But we want to stay general, okay? So instead of saying if segment A, B, and C, D are 8 units, then A, B, and C, D are congruent. What do I know about these? Well, they have the same length. So I have segments with the same length, and I want to conclude that that would make them congruent. So your wording is probably going to say something like this. If segments have the same length, or you could say the same measure, then they are congruent, okay? All that's going on there. If segments have the same length or if segments have the same measure, then they are congruent. Okay, the if part matches the given, which is some lengths. The then part matches the conclusion, all right? Second one here. Same thing, we're given two angle measures. That one's 70, this one over here is 70. We want to say the two angles are congruent. Well, what makes angles congruent? Having two equal angle measures. So I'm going to say something about, remember my if is going to go with my given, my then is going to go with my proof. So something about having the same measure leading to congruent angles. And if you see vocab, if you see symbols, you know, that vocab needs to be in your final if-then statement, okay? So I would say something like, we're dealing with angles. So if angles have the same measure, then they are congruent. All that's going on there. All right. What's going on here? Angle M is a right angle. Angle P is a right angle. We want to conclude that they are congruent. Okay, now you do have to be careful here. Right angle is a classification. It is not an angle measure. Okay, and if you remember, we have a special theorem here, so we don't have to do an extra step and say that those right angles are 90-degree angles. We now have a theme that says that if we have right angles, that we're allowed to say they're congruent. So that's all that's going on here. My if is going to go with this information. My then is going to go with this kind of information. So that would be if angles are right angles, then they are congruent, okay? And that is a special theorem. So if you're wondering why are we allowed to mention what kind of angles we have here, because we have a special angle for we have a special theorem for right angles and for straight angles. So that's the only one where you can say what kind of angle it is specifically. All right, what's happening here? G and H are bisecting the segment. Okay, notice it's a segment being bisected, not an angle. So if the segment's bisected, that's going to give me congruent segments, and that's what we can see down here. Okay, so same kind of thing. We want to have an if statement using the vocab, saying something about trisecting, probably points trisecting a segment, okay? And then we want to conclude in our then something about getting some congruent segments. So I would say, you can do something kind of low level and just say, you know, if a segment's trisected, then it's divided into congruent segments. You can be a little bit more careful with the wording. We have points doing the trisecting, so we could say if points trisect a segment, then they divide it into congruent segments. That's all we need. All right, and 2 to go. We're told that we have 2 congruent segments here, and we want to conclude that we have a midpoint. So again, our if usually has to do with the given, then usually has to do with the conclusion or proof statement. Be careful here because your wording could end up saying something false. You don't want to say something like, if there are 2 congruent segments, then there's a midpoint. Because first of all, you know, that could be something like this, where I have 2 separate congruent segments, and there's no midpoint there just because those 2 segments are congruent. Even if you said if 2 segments are connected and they're congruent, then they have a midpoint. You could have something like this, okay? A midpoint has to be on the same line segment. You've got to have two equal parts on either side of that point on the same line segment. So the wording I like to use for this is saying something about the point itself dividing a segment. You got to have a big segment for the whole thing to be able to have a midpoint. So talking about a point dividing a segment into congruent segments. So if a point divides a segment into congruent segments, then it is a midpoint. Something like that, okay? Our if part matches the given, our then part matches the vocab in that proof statement or conclusion. All right, and final one here. We've got two congruent angles, these guys right here, and we want to say that the angle's been bisected. So my if part has something to do with the given, then part has something to do with the proof. Basically want to say something about an angle being divided into two congruent angles, meaning that it was bisected, okay? So I think I'll just word that as if an angle is divided into congruent angles, then it is bisected. Short and sweet, to the point, okay? So again, your if part should match the kind of thing that you're told. So we've got our congruent statement there, that kind of thing. And then our then statement should say something about the vocab that's there, which in this case is bisecting. And that's what we've got.